And after approximately 2 years, it's time we discussed one of the older papers that actually made an incredible discovery. A discovery that's been 50 years in the making. And that's because for decades, astronomers have predicted the existence of some of the most bizarre massive objects in the universe. Lonely supermassive black holes traveling across space without much fanfare and without making themselves too obvious. And that's because these black holes escaped their home galaxies and became wandering black holes, moving through the darkness of intergalactic space for billions and billions of years. And theoretically, quite a few of these black holes should be all over the place. And that's because they're usually produced as a result of various galactic interactions and especially galactic mergers. But the thing is, until recently, we had absolutely no proof of their existence. Even though there have been some clues here and there, nothing definitive has been discovered until the last few years. And well, hello wonderful person, this is Anton. In this video we're going to discuss a definitive confirmation of at least one such supermassive black hole that you can kind of see in this image next to me. And that's because after 2 years of debates, we finally have definitive proof that this seems to be the first ever runaway supermassive black hole, currently zipping through space at nearly 1,000 km per second and producing the contrail you see in this image. This is now referred to as RBH1, Runaway Black Hole 1. But this is not the first time we've discussed this particular image, because originally this was discovered back in 2023 completely by accident. And so here, while looking at archival Hubble images, specifically focusing on a galaxy known as RCP-28, scientists behind that 2013 study, the link for which you can find in the description, discovered this really unusual line, and a very thin line, kind of resembling a flying bullet. And initially this was assumed to be maybe some kind of a camera artifact, or even some kind of a cosmic ray just passing through the camera lens, mostly because it looked so bizarre. But the additional observations and additional confirmations showed us that this was a real object and contained a lot of gas and relatively young stars stretching approximately 200,000 light years. That's about twice as big as the Milky Way galaxy. And so the first explanation here was, of course, that this was a supermassive black hole that escaped the galaxy nearby and that was basically forming something like this, a contrail of stars. But not everybody accepted this, and the initial explanation was not particularly satisfactory. And so almost right away we had a counter-proposition and actually a very good counter-evidence. It was from the study you can find in the description, and well, as you can see from the title, they claim to have solved the mystery. And that's because this was now explained as an extremely thin disk galaxy that we were just observing from the side. In other words, instead of looking at this face-on, you were just seeing the side. And here they actually provided quite a few additional examples of extremely similar galaxies that basically produce very similar shapes. And so what was initially thought to be a wake from the runaway supermassive black hole was now suddenly explained as an edge-on view of a bulgeless galaxy, with one of the best examples that looked exactly like this being IC 5249, a galaxy that also looks just like a single line. And that did actually make more sense because the object in this case was extremely large, once again 200,000 light years, which would be similar to a typical galaxy and would not require an explanation involving some kind of a very bizarre contrail. Something that, by the way, we've never seen before. We've actually never seen anything like this after decades and decades of research. But that's where this new research from just a few weeks ago comes in, because the original team, led by Petrov, did not agree with this explanation and wanted to confirm that this was indeed a runaway black hole and not a galaxy. But to confirm this, they needed one particular piece of evidence. They needed to find some kind of a shockwave that's actually being formed by the black hole as it moves across the intergalactic space. In other words, they needed a smoking gun to prove that this object was moving at a high velocity and was producing a lot of additional interactions. And for this, they used the James Webb Space Telescope. And so here, by using JWST's near-infrared spectrum observations, they looked at the tip of this 200,000 light-year long object. And they really wanted to find the bull shock. Basically a wave of compressed gas created when an object moves much faster than the speed of sound through a particular medium. This is of course something we usually see in the atmosphere and in the ocean when the objects move really fast. And well, to everyone's surprise, JWST data provided the proof. Here scientists discovered a very sharp change in velocity right at the tip of the object, specifically a jump of about 600 km per second over an extremely small distance. This kind of a steep velocity gradient is exactly what you would expect from a typical bow shock. And that of course was an extremely important piece of evidence. It provided empirical validation that these supermassive giants can indeed escape their galaxies and then travel at extremely high velocities, disturbing the intergalactic gas and even causing star formation in their wake. Which is exactly what seems to be this contrail that's left behind. And so here, a massive black hole approximately 20 million solar masses seems to plow through this intergalactic gas so fast and creates so much pressure that it then leaves behind a very long line of newly formed stars, which seems to be the main explanation for this very strange line. And though obviously a bulgeless galaxy would be a much more convenient explanation, right now this would not explain the shockwave. With the next natural question being, okay, so how exactly did this happen? How would such a massive black hole leave such a small galaxy? And well, according to all of the research we have, there seem to be two main ways. Both of them involve a lot of galactic interactions. First, we have what's known as the three-body slingshot. Basically, imagine two supermassive black holes orbiting each other after galaxies merge, and then there is suddenly a third galaxy that delivers a third black hole. And these three massive objects then start to orbit and create a gravitational instability. That's of course the famous three-body problem. And one of the solutions to this problem is that one of them gets kicked out, and usually with a lot of energy. Normally this involves the lightest of the black holes. That of course implies that the other two are much more massive. Alternatively, there's also the idea known as gravitational wave recoil. This is what happens when two black holes merge, and as a result they also release gravitational waves. And sometimes during the merger, there's a kind of a bias toward one direction, where a lot more waves are emitted much stronger in a certain direction, which can then give this newly merged black hole a tremendous kick in the opposite direction, which can then create these supermassive runaways. And, well, based on the initial analysis here, it looks like this black hole has only been traveling for approximately 70 million years, ever since it's left its host. It's not clear exactly what formed it, but we can kind of see the host in one of these images. And this is of course a really important discovery for astrophysics. It basically confirms that sometimes some galaxies can indeed lose their own black holes, with these black holes then traveling across and forming these bizarre star structures that don't actually qualify as clusters or galaxies, but instead are basically just a line of stars left behind when the black hole passed. And that also explains why we've seen some galaxies, including the nearby Triangulum galaxy, that seem to have no central black hole. In other words, we now have an explanation for why this galaxy seems to have nothing in the center. But this also raises the question of, so what happens to them afterwards? And moreover, what happens to all of these stars and all of these additional structures formed by this fast-moving object? Because in this case, the wake itself is also fascinating. Here, as the black hole travels, it doesn't just consume everything in its path, but instead, because it's moving so fast, once again almost 1000 km per second, and by the way, if you were to move at this speed, you would get from Earth to Moon in just 14 minutes. Here, this extremely fast motion actually compresses the gas, triggering a massive star-forming region in its wake, which most likely results in a lot of hot blue stars. And so in some sense, this invisible monster is actually creating new life in its wake. And that means that there's probably so much to discover here because this is the first such object we've ever seen. But it's not the first unusual supermassive black hole discovered in the last few years. Because not so long ago we've also talked about the cosmic owl. A very strange structure containing two galaxies, but three supermassive black holes. And one of them is right in the middle. And though at first it was believed to be a runaway black hole as well, last year scientists confirmed that this is actually the first ever baby supermassive black hole that seems to have formed right there as a result of massive amounts of collapsing gas because these two galaxies are merging. And well, except for these two cases, everything else so far has been kind of ambiguous and there's just not enough evidence. But in just the last year or so, we have now confirmed two super exciting objects, or I guess very exciting supermassive black holes, that though have been predicted to exist, have never been physically observed and have now proved a lot of different theories. Which means that now scientists are going to focus on trying to find more of these similar objects, even though they're kind of difficult to see because, at least in this case, this is just an extremely thin object that's very difficult to identify. But scientists are now pinning their hopes on the upcoming wide field surveys, such as the ones by the Euclid telescope and the Nancy Grace Roman telescope. These telescopes are designed to scan a large portion of the night skies and could definitely help us identify a lot of these runaway monsters. But at least for now, this is a super exciting discovery. The first confirmed runaway supermassive black hole in the history of astronomy. And though it might sound a little bit scary, especially one of these objects could be slowly moving toward us, honestly that's extremely unlikely, so there's obviously nothing to worry about. Anyway, once there are some additional discoveries, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access and a few more things. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.